Today we're going to get started with Chapter 2, specifically with Section 2.1. So in Section 2.1, we are going to understand the concept of perpendicularity. So let's talk about what it means to be perpendicular. Perpendicular means that we have lines, rays, or segments that intersect at right angles. So it can be two lines or two rays or two segments, or it could be a combination of two of those three. Okay, so there's many different types of pictures that you can sketch. So like I said, it could be just two lines. So say here's a line, I'm going to call it line L. And then here's a line, I'm going to call it line M. Okay, because remember, you can name lines with one lowercase letter if you don't have specific points on the line. But just because I have two lines intersecting doesn't mean they're perpendicular. Perpendicular intersects at right angles. So I would have to know that I have at least one right angle in this picture in order for me to then state with notation that line L is perpendicular. So this is the symbol for perpendicular to line M. Okay, so essentially it looks like an upside down T because once again, then when it looks like that, you're not going to have it, but it then like you could have a little box there that indicates that you have a right angle. So it's just an upside down T that represents the symbol for perpendicular. Okay, I could have a segment. So I'm going to call this the segment AB. And I could have then the ray BC, and as long as they intersect at a right angle there, then I could say that, sorry, my pen's not been the greatest here, that the segment AB is perpendicular to the ray BC. Okay, so a couple different sketches to represent then this idea of perpendicular. So let's look at an example. So given that the line EH is perpendicular to the line HG, we want to name all the angles that we can prove to be right angles. So remember, you cannot assume right angles. So because we were given perpendicular, that's what's going to allow us to state right angles. I'm going to highlight the two lines that they're talking about. So EH is this line right here, and HG is this line right here. So it's only where those two lines intersect, that's where we're going to be able to state that we have a right angle. So notice that those two intersect, and so this big box right here is what's forming then that right angle. So name all the angles to be right angles. Well, I can't just say angle H because I've got 1, 2, and then that really big angle. So there's actually 3 angle H's. So I have to use 3 letters. So I'm going to say the angle EHG. I could have switched it around and said angle GHE, but either way, that is actually the only spot where I see a right angle. These two little angles down here, which I called 3 and 4, you are not going to be able to say that they're right angles. Even though they might look like it, I don't know anything about being perpendicular over there, and so I cannot assume right angles. So angle EHG is the only angle that we can absolutely prove to be a right angle based off the given information. Okay, we're given in this picture that the ray KJ is perpendicular to the ray KM. So I'm going to mark that in my picture. Perpendicular means that where those two rays intersect is going to form a right angle. Angle JKO, so this angle right up here is 4 times as large as the angle MKO, which is this little angle down here at the bottom. So because one angle is 4 times larger than the other, but I don't have a representation of what that measure actually is, I'm going to call the smaller angle X. And so if the other angle is 4 times as big, that's going to be 4X. So now I'm going to have enough information where I can solve for X, because then they ask for the measure of the angle JKO. If I don't know what X is, I can't then find the measure of that angle. But those two smaller angles are forming a right angle. So 4X plus X has to equal 90. Combine my like terms to get 5x. Divide by 5. And we find out that x is going to be 18. Now, if they were asking for x, we would be done. If they were asking for the angle OKM, we would be done because x represents that. But we're not. We want the measure of the angle JKO. So since that's represented as 4 times x, and we just found x to be 18, 4 times 18 is going to give us our angle measure. Because we are talking an angle, it is in degrees, so I'll put the little degree symbol. If it was a segment, then I would not put the degree symbol. But it looks like this angle is 72 degrees. All right, here it says the line DE is perpendicular to the line EF. Right now, I don't have a picture, and so that's what I'm going to draw first. Perpendicular means that when I'm drawing these two lines, I want them to intersect at a right angle. So the line DE and EF. I knew that I had to put point E here at where they intersected because I need that point on both of the lines. Okay, but I know that perpendicular means that we've got right angles. So there's that first sentence. It says the resulting angle is trisected. So this right angle here, they're telling us now is being trisected. If something's trisected, that means that it gets divided into 3 congruent pieces. So I'm going to trisect that angle. And so hopefully we notice that then each of those angles are going to have to be then 90 is the whole angle. If it's trisected, it's divided by 3. So now each of those new smaller angles, like if I named this with point A, this is point B. So we have angle DEA, that's 30 degrees. AEB, that's 30 degrees. BEF, that's 30 degrees. So all of those angles are 30. The next part of that sentence says, then one of the new angles is bisected. So that means that between those 3 new angles that are 30 degrees, one is being bisected. Remember, bisect means to divide into 2 equal pieces. So I'm going to just go with the middle angle of AEB. If it's being bisected, that's now creating these angles here of angle AEC and CEB. Well, 30 degrees was the angle AEB. If it's being then bisected, it's being cut in half. 30 divided by 2 tells us now each of those smaller angles are 15 degrees. The last part of that second sentence says, then one of the resulting angles is trisected. Well, once again, trisect means to divide into 3. So between those 2 angles, AEC and CEB, I'm going to trisect it. So I'll do it with a different color so we can kind of see what's going on. So I'm going to do the angle AEC. If I trisect, that means that I'm dividing that into 3 equal pieces. So that means that this little angle, and this little angle are all the same. So that means that the 15-degree angle being trisected gets divided into 3. 15 divided by 3 means that each of those little tiny angles there have to be 5 degrees. And that's what the question was basically asking for. It said, how large is the smallest angle? So one of those smaller angles are all those little angles in the middle, and we just determined that it was 5 degrees. All right, here we have an error analysis problem. It says Joe is unsure of his answer to one problem from a recent assignment. If you agree with Joe's answer, explain how you know his solution is correct. If you disagree with Joe, identify his mistake and solve the problem correctly. So here's our given information. We are given that the ray GF is perpendicular to GH. So perpendicular, we just talked about it, means that we form right angles. I'm going to start marking that in my picture. So forms right angles. I've got a right angle there. We're told that angle 1 is x plus 18. We're told that angle 2 is 2x plus 6. We're told that angle 3 is 3x. So if we start looking at Joe's work, notice that he took each of those 3 smaller pieces, the x plus 18, the 2x plus 6, and the 3x, he added them up and set it equal to 90. Well, I agree with that because we know that we have a perpendicular right angle here. That's why I had to add all 3 and set it equal to 90. So let's make sure that his algebra checks out. So x plus 2x plus 3x, I agree that that combines to 6x. 18 and 6 combine to 24. So then it looks like he subtracted 24 over to the other side, which is why it's 66. Then he divided by 6 and got x to equal 11. So far I completely agree with Joe. His work seems to be legit. But he stopped at x. He said x equals 11. You got to make sure that you're reading the problems all the way through. Notice that in this particular problem, the question doesn't say find x. Instead, the question asks, is the angle FGH trisected? So I'm going to say, while I agree with Joe's setup to solve for x, he did not fully answer the problem. Okay, so that's me. Yes, I'm kind of agreeing, but I'm also disagreeing. So that means that I need to finish and solve the problem correctly. So while I agree that x is 11, now to determine if something's trisected, I'm going to figure out what's the measure of each of these small angles, because then remember, to be trisected means to be divided into 3 equal pieces. So I'm going to substitute the 11 in for each of those x's. So we're going to have, we're going to have 11 plus 18 for the first one. We're going to have 2 times 11 plus 6 for the second angle, and 3 times 11 for the third. Well, 11 plus 18 is going to give us 29. So that's a 29-degree angle. 2 times 11 is 22. Add 6 onto that, we get 28 degrees for that angle. And 3 times 11 is 33. So, unfortunately, because those 3 angles are not the same, I would say no, the angle is not trisected. And so my work right there just justifies why it is not being trisected. All right, and so that is us understanding the concept of perpendicular.